Okay, so Google has just released Gemma 4. That's its open model that you can download and run locally on your own hardware. So you're not sending things up to the cloud. And of course, there was Gemma 1, 2, 3, 4. And as you'd expect, these ones get better. They're more efficient. They are better answering questions. And this is free for you to download and run on your PC right now. So that's what we're going to talk about today. There are 4 models available of Gemma 4 and they fall into 3 different categories. These first 2 here are the effective ones. So there's an effective 2 billion parameters, an effective 4 billion parameters. But in fact, they actually have 5 billion and 8 billion respectively. And then they've got some clever stuff in there to mean they're running very efficiently with effectively only 2.3 billion parameters. And then you've got the really, really big one. This is the 31 billion dense one. Okay. And then as you can see, things like the number of layers is different. The context length is different. Lots and lots of differences between them. So this is the most intelligent one, but it's also the slowest. This is the least intelligent, but it's really, really fast. And then you've got some things in between. Now, the third category is this mixture of experts model. So it's a 26 billion model, but it only has 3.8 billion active parameters, 256,000 token context length, which is really good. And this is actually pretty quick because it's using, again, this mixture of experts, which means it kind of picks which part of the model it needs to run in different circumstances. So there are the 4 models that are available, all free to download. It depends on what hardware and things you've got, on which one you want to do, on what use case you want. There'll be a difference in running this on a low end, let's say an embedded SBC, a Raspberry Pi, and of course running it on a NVIDIA DGX Spark or something. But the important thing is to look at the benchmark. Now, of course, this is just a load of numbers, but it does give us a feel. Now, let's just look at this first line here. First of all, you can notice that the results drop off as you go across the models down to the lower ones. So you get 85% for the big 31 billion one, and then that drops down to 82%, which is not much of a drop, and then down to under 70%, so quite a big drop, and then down to 60%. And then this is asking, how does that compare to the previous models? Well, Gemma 3, this was only 67%. So this is a huge leap in performance. That was the 27 billion parameter one. So this model is a huge leap. It beats it across the board, except for the very, very tiny, tiny one. Now, if you compare that to the current results from ChatGPT 5.2 and Claude Opus Gemini 3 Pro, you can see that 85% is not too far behind the current commercial ones that are up running in their huge servers in the huge data centers in the cloud. You're going to kind of get this. And especially if you run this one, this gives you a good mixture of performance and capabilities. Very, very close to what's going on there. Now, I haven't been able to find exact matches for all of them. But again, let's look at this live code bench V6. Again, you can see it drops down as you go across the board. But look at this, 29% it was on Gemma 3, but even the tiny one here, 44%, just blows it out of the water. And 80% here again is close to what you're getting on the big ones running up in the cloud. Again, the same here. We can see this benchmark here, Tau 2. Again, you get the drop. But again, look at the difference in Gemma 3, the big Gemma 3 model, and the rest of the models. So again, this is a huge leap of capabilities. Okay, so I want to take a quick pause from the video to tell you something cool, something that's been a game changer for my audio setup. Now, this segment is sponsored by Mono, who have hooked me up with their PD200W hybrid podcasting microphone. Designed for podcasting and streaming and content creation, it offers greater levels of freedom because it's wireless. Declutter your desk, no more wires. You just need to plug the USB receiver into your computer. For even more freedom, you can just plug the receiver into your iPhone or Android phone, giving you a completely mobile pro setup. Now you are free to record anywhere, anytime. At your desk, on the sofa, even outside. Now here I am doing a screencast. Now the thing is, when I'm typing on my keyboard, you can pick it up. Please write a song about walking in the hills while thinking about noise cancelling microphones. Okay, I can go and do that. Now, luckily, this microphone does have noise cancelling, so I can now switch it on so I don't get that annoying tappity tappity tap as I'm typing in. Let's try that. Okay, so now with it switched on, write a poem about walking in New York. And there you go, there's our poem, and also you could hear that the key presses were nowhere near as pronounced. Now, wireless means freedom. Well, how much freedom? Up to 60 meters. On top of that, there's up to 60 hours of battery life. Now, if you do the maths, think about that. That's actually 2 hours of recording a day for a month. There are also apps for Android and iOS, so you can configure and control the PDW200 hybrid. If you're using it on a desktop, Mono has you covered with software for Windows and Mac OS. This mic makes it effortless to blend wireless freedom with pro-level clarity. Whether you're podcasting or streaming or doing content creation, or you just need clarity in those online meetings, the PD200W hybrid does it all. So if you're curious about leveling up your audio setup, then check out the link in the description below. And the other interesting thing about Gemma 4 is that Google has worked together with NVIDIA, or NVIDIA has worked together with Google to make sure this stuff works really well on NVIDIA hardware. And that means everything from a DGX Spark all the way down to a Jetson Nano, and of course a PC with an RTX GPU in it as well. So Google and NVIDIA have collaborated to optimize Gemma 4 for NVIDIA GPUs. The new multimodal and multilingual models are built for fast, efficient and secure AI access across devices, and are optimized to run locally on an RTX, RTX Pro, DGX Spark and the Jetson. That's of course a quote from NVIDIA there. And NVIDIA are saying that if you compare this to an Mac M3 Ultra, this is the speed up you get if you use these models on an RTX 5090 in your PC. So you can see up to 2.7 times faster than what you get on an M3 Ultra. So the Mac Minis have been very, very popular for people wanting to run local AI models, but that isn't necessarily the best way to do it. Now, this is my own testing here. Now, basically, I've got each of the models here and their sizes for reference, and then basically the speed that you get using an RTX 5090. And as you can see here, the very small model, the 200, gives you 278 tokens. It literally flies past. And I'll show you that running in a moment, just to show you how fast it is. And then the question is, does it answer the Alice question? Well, the answer is yes. Alice has 5 brothers and she has 3 sisters. How many sisters does Alice's brother have? Now, the smaller models would always fail with this. They just couldn't do it, but it was able to do it. That just shows you how far Gemma 4 has come along. And then the hourglass question it couldn't answer. So basically you've got 2 hourglasses, a 7-minute one and an 11-minute one. How do you measure 15 minutes? The question is a bit more fully expressed when I actually type it into the LLM. Now, this one couldn't answer it, neither could the next one, the effective 4 billion parameter ones, but that one runs at 193 tokens a second, and it can also answer the Alice question. But the real star of the show, I think, is this one. It's the Gemma 4 26 billion parameter, which is effectively a 3.8 billion parameters, and it runs at 183 tokens a second, which is really fast, and it can answer the Alice question and it can answer the hourglass question, and I'll show you that running in a moment as well. And then the big heavy one, the dense one, 31 billion parameters. Well, it's 31 billion parameters, and I was running it on this RTX 5090, only manages 2.2 tokens a second, so very, very slow compared to the other one. So the real star, in my opinion, is the Gemma 4 26 billion parameter one, because it can answer the hourglass question, it can answer the Alice question, and it runs really, really fast. And the other thing to note is that if you're using like llama with these models, which is what I've been doing, you can also use them with things like Claude Code, Codex, and even OpenClaw. So this is really interesting. So people are worried about token budgets and burning through your tokens using OpenClaw or even using Codex. Now you can run it against Gemma 4, and of course you're not running about your tokens because you're getting it all locally. And I'll show you that running in a second as well. Okay, so here is the Gemma 4 26 billion token one. And I'm going to ask it this question that I've asked many, many ones. You are an English teacher. Helping a student with an exercise, it's important that you follow these instructions precisely. Read the following text, then pick the most unusual word. Find a one-word synonym for that word. Take that synonym in and reverse it. So, for example, the opposite of spoon is noops. Okay, so this is really having to follow lots of instructions, text comprehension, picking a word, then reversing, finding a synonym, then reversing that word. Okay, let's just go. And you can see it's already running here in the thinking mode. And look how quickly those tokens are flying past. This is the 26 billion parameter mode. Absolutely brilliant. Running on my RTX 5090. And let's see what it says at the end. Okay, so it's gone through, it's found quixotical, which is normally the word that I would pick. Idealistic is its option. And then have we got IDEAL? Idealistic, fantastic, got it right. So there you go. So it did all that. And look how quickly it did it. And that's running locally here on my PC. Okay, so now I've switched over to the Gemma 4 effective 2 billion parameters. I'm going to ask it this question. Write a review of the 1977 film Star Wars Episode 4 A New Hope, in which each sentence begins with a consecutive letter spelling the director's name. So George Lucas. Use only short sentences. Let's hit go. Look at that, doing its thinking. And there's the answer. Blindingly fast, running here on my local PC. G, great action begins immediately. E, epic scope defines the galaxy. Outstanding visual effects are present, and so on. So that's, and if you follow that, it does spell out George Lucas. Spectacular filmmaking remains a classic. So well done, Gemma 4 effective 2 billion model. And you can use the llama launch command to launch Codex. So I'm actually in Codex, but it's using the Gemma 4 model, and then you can start using it. So create a service that takes you long URLs, I'm saying generate short codes, and it goes ahead and just like Codex would, is analyzing that, going back and forth. And because it's using one of those faster models that we were just about, not the 31 billion dense one, it's using one of the ones that gives out hundreds of tokens a second, then actually this works pretty quickly. About a minute's gone past as it's been analysing that very first part of the request, and now it's going into the normal Codex thing you'd expect to happen. So there you go, Codex running using Ollama and the Gemma 4 model. Okay, that's it. My name's Gary Sims. This is Gary Explains. I really hope you enjoyed this video. If you did, and I really hope you did, please do give it a thumbs up. If you enjoy this channel, I recommend that you subscribe. And if you want to support the channel, then please go ahead and join with one of the memberships. Okay, that's it. I'll see you in the next one.